Hello students, Ms. Slyman here. This is a really nice problem that I encourage you to think about on your own before watching the video if you haven't yet, or maybe stop the video after a little bit and try and continue thinking about it on your own. So the first thing, this figure, we should have been told that it's a square figure. So given the square figure, if the indicated shading process continues indefinitely, write an expression using sigma notation that represents total area. So if it continues indefinitely, we're saying that the sum of all these things would reach a finite area, even though we're continually going smaller and smaller. So mathematics tells us we can always keep going, we can always find a new box, but we're fixed inside this area. So let's look at this. So if we assume that the sides of my square, we can make any sort of assumption. I'm going to assume that it has sides of x. So this shaded area, my first area, is 1/4 of the whole square, so 1/4 of x. So A1, I'm going to call it x squared over 4. A2 is now 1/4 of this square. So A2 is 1/4 of x squared over 4. Of course, that's x squared over 16. Area 3 is now 1/4 of this one. So 1/4 squared times x squared over 4. Hopefully you're seeing it's geometric. It's geometric with a u1 of x squared over 4 and an r value of 1/4. Well, since r is less than 1, it is possible to find the sum to infinity. So sum to infinity, u1 divided by 1 minus r, x squared over 4 divided by 3/4, x squared over 3. So the sum of all these gray boxes is going to end up being a total of 1/3 of the original area. So no matter the size of the square I start, if I continually fourth it and add up all those areas, I end up with 1/3 the size of the box. Super cool.